Okay, so today's topic is, we're going to dive more deeply into variable scope and instance variables and class variables. We're going to talk, I mean, we've covered those, but they deserve kind of a little bit more. What we're going to look at is basically these are the three types of variables that we have. There are no other. But it's important to understand what the difference is, and there are some key differences as far as how they get initialized. Okay, so let's talk about local variables. And again, we've been using local variables pretty much since the beginning. Local variables are declared inside of a method. The formal parameters of the method, they create automatic local variables when the method is invoked. Okay, we'll see what that is about. And this is important to understand, that when the method finishes, all of the local variables basically get tossed away. And that includes the formal parameters. This is one of the key things, that the instance variables, however, which are declared at the class level, they exist as long as the object exists. So if you are in a situation where you want a value to persist beyond more than one method calls, then it must be, well, an instance variable. And technically it could be a class variable, but for now, focus on instance variables. Instance variables are what the majority of this is all about. It's important, though, to understand what local variables are and are not. So again, a local variable does not persist from one call of the method to the other. When you call it again, it all gets reinitialized, and there's some implications to that. So this bank account example that the book goes through, again, I take a little bit of issue with some of the details of how the book implements it. But part of the idea is that we have a class named account that's going to represent at least a little bit of information about the account. Again, we're obviously, if we're actually doing some software to represent this for a bank, there's going to be a whole lot more stuff in this, but we're going to start simple. So right now, the state is going to be the account number, the balance, and the name. And of these, the account number and the name are going to be, once you set them, they're not going to change, but the balance is going to change. Now, we talked about methods being behaviors or services, and basically there are going to be three. We're going to deposit, we're going to withdraw, and we're going to add interest. Okay, so those are the three behaviors. So when we're designing a class, and this is something which is useful when you're designing a class from scratch. So far, at least in the beginning, the design will kind of be given to you like this. And the main tool that we have for designing the structure of a class are these UML diagrams. And here's, again, what they mean. The static variables are underlined, and if it's not underlined, it's an instance variable. So these are instance variables. Instance. And then we have a constructor. If there's more than one constructor, then they would be listed here as well. These are the regular methods. Let's see, do I have little? No, I don't. These are the methods, the instance methods that are written here, and then in italics, this is something which is overridden. So an override is where, and not responsible for this yet, but every class has a two-string method, and that's defined in the basically in the base, what's called the base class. You're not responsible for that yet. You will be later. And the thing is that when you have a public method, then a subclass of that can override it. In other words, replace it with something else. And that's what we've done in a couple of different classes, where starting like the die class, for example, and then likewise in the playing card class, you overrode the two-string method. And that, what's the advantage of that? The advantage of that is that when you just print the object, then what it does is it calls the two-string method of that. Okay, we'll dive into that a little bit more as the course progresses. Okay, but this is the design of the class. Okay, so when you see this, you can instantly translate these. Take this and make this a static final. This will be a static final. These would be instance variables. And remember, instance variables must be declared to be private. And then these are the constructor, and then instance methods. And these are declared to be public. Okay, so the idea, and this gets back to the encapsulation idea. Instance variables declared private to enforce encapsulation. Instance methods declared public to make the objects live, to make them be able to do something. In other words, for this account, if we have, for an external client of this account, we want to be able to deposit, we want to be able to withdraw, and we want to be able to add interest. And then in addition, we want to be able to get the balance for that. Now, the way that this is designed is that the deposit method, and again, this is, how should I say, all that the UML diagram does is it shows you the structure of the class. It doesn't say anything about how these are implemented. So you look at this, okay, what does this mean? This means that the argument to the deposit method is a double value. And then when you write it, you can't just put double in there. You have to put double and then give a formal parameter for it. It returns a double. Now, what does it return? Again, the UML diagram doesn't say that. That has to be specified somewhere else. So somewhere, if you're documenting this somewhere else, you would say the deposit method, you give it the amount that you're depositing, and you return the resulting balance. And likewise with the withdraw, you notice that there are two doubles here. Okay, what are they? Well, the way that this was designed is that the first argument is the amount that you're withdrawing, and then the second is a fee that they're going to charge. I wouldn't go to this bank if they charge you just to withdraw your money, but that's just what it does. And what does it return? It will return the resulting balance. Likewise, here we say we're going to add interest. There are no arguments because the interest is going to be dictated by this rate here. So we don't have to tell it anything. What that will do is that will take the current balance, basically add the rate in and return the resulting balance. And then it gets get balance is just going to be the getter for it. Okay, so this is the text version. There's a version in GitLab that I posted that's a little bit more to my liking. So for example, for something like this, I wanted to make that static. But again, notice these are instance, no static here. Okay, so now here's our constructor. The constructor, we give the owner, we give the account number, and then we give the initial balance. Okay, so let's dive into some of these methods. In fact, let me show you mine instead. Okay, so just okay, everything the same except that again I added the static to this because when you have constants like this, it's a better design to make them static. When you have these must be instance variables. Okay, so now I did this a little bit different, and I'll come back and sort of explain a little bit about what's going on with that. Let's look at the deposit again, and notice that for some reason the book doesn't use JavaDoc. JavaDoc is something that I will require, and the difference is instead of the double slash or the slash and a single star, it's the slash and the double star. And the idea is that the UML diagram tells you what the structure of this is. The JavaDoc tells you what it's supposed to be doing. Okay, so when I deposit a certain amount, then I simply add that to the amount and return the balance. Okay, likewise, withdraw, there's a fee. And so I subtract the amount and the fee from the balance. Again, this is slightly different than what the book does. Is who's correct? They're both correct. This is just a little bit more, it's just a different way of doing it. And then likewise, the balance. So here I'm multiplying 1 plus the rate. And then there's the getter. Now here we're using and this is kind of the way the book does it as well. And if you want to represent currencies, then formatting them this way is a useful way. What I've done here, and I haven't shown you this, but we've seen this in the printf when we use printf. And it turns out that the string class has a method called format that uses the same structure. So we can exploit that in this particular case by, instead of concatenating a bunch of stuff together, we can say, okay, I want the name, the account number, and then the balance expressed as a string, and I'll format it using this currency instance here. So, yeah. Okay, there are transactions. Let's come on. Okay, so here we just create a bunch of accounts. Now, notice that because I'm putting this in the CS2173 run package, I need to import the account class. So this is exactly the same as the book's example. So we're just going to make some deposits, check our balance after that, withdraw some, add interest, and sort of see what the result is. And we pretty much get the same thing. Now, let me circle back to my constructor here a little bit, because this there are a couple of items about this. Notice the word this. If you might remember, if your Python class used some, the Python version of object-oriented stuff, they have a word, a keyword that refers to that particular object. In Java, it's called this. And they use this from, they borrowed that from C++ because that's the word that they use. And it's a terrible word because it's not very descriptive, but that's the one it is. This refers to the object that you're in. Now, here's the thing, and we're talking about local variables versus instance variables. Local variables and arguments to a method or a constructor are like local variables. So here's the thing is that what if I have a local variable and an instance variable of the same name, then which one gets used? And the answer is the local variable. So a local variable will shadow or basically be used in place of the instance variable. Now, NetBeans helps us out here by putting our instance variables in green. Local variables stay in black. So name is a local variable because it's a formal parameter of the constructor. So how can I distinguish that name from this name? And the answer is this keyword this. So you can never go wrong referring to an instance variable or even an instance method by using the keyword this. And the thing to understand is that when you refer to an instance variable or an instance method, the format is always the same. It is an object.method or object.variable. That is always the case. Now, you might ask then over here in the deposit, for example, we just use the instance variable called balance without any this. Why? Well, because inside the class, if I refer to an instance variable without any modification, then this is implied. The exception being a case where a local variable has the same name. So, I mean, and the same is true of instance methods. So for example, in the toString method, so here I was directly referring to name, but I could also say get name instead. Or did I have, I didn't have a get name, never mind. Here I had a get balance. Should have been a get name, but there wasn't, it wasn't the design, so it wasn't there. So here I can say get balance, and that will refer to the instance method I have here, but the full way of calling it is with this. In other words, it is always, when I call a method, an instance method, it's always object.method. But inside the class, Java and I think correctly said, well, that's a lot of typing. So so if I'm inside the method, then I can leave off the this and it will basically stick it in for me. Okay, so where are we here? Where's my? Okay, so and then you notice that here, okay, what's the difference here? They just kind of concatenated the values like this, and then there's nothing terribly wrong with that. It just that when it's, I find it just a little bit nicer to use the printf formatting type of stuff. Okay, so the driver program, you don't have to remember that name, but basically the thing to understand is that these classes that we are writing using the main methods, the key thing about them is all we're doing with them so far is testing the other parts of the software. These driver programs are in and of themselves not important, except to verify that our classes are doing what they were designed to do. That is their only purpose. So, and that's why producing the output is not really the important thing. The important thing is whether the class has been written correctly. So again, here's their version, which was pretty much identical to what I had. Okay, so just kind of peeling back the hood on this a little bit, this variable, okay, when that was defined in the over here, so that was defined right here. Again, remember that that is simply a reference to the object that was created. And when it was instantiated using new, so this was created using new. If we did not instantiate it, then we got null. That's the important thing to understand. Okay, so what this kind of expands a little bit is that because the account number and the balance were both primitive values, where they were stored, with just the value was stored somewhere. But name was a string, and string is an object, and so the name variable itself was likewise just a reference to a string object that was somewhere else. And likewise, the second one, again, the contents of the account number and the balance as primitives contain the actual value, but the name instance variable is simply a reference to the string object. Okay, and this is, so how do we know which accounts object is updated? Well, because that's the object that it was called on. So every object is referenced by an object reference variable. So in this case, my account, and then when you call it from the outside, then you have object dot method. Okay, and that is always the case. As I was pointing out earlier, inside the class, what it really is inside it is this dot method. Okay, however, just to save a little bit of typing, we can leave that off. That is optional. Now, there are a lot of improvements that need to be made. Well, one is you want to have, well, you don't want to have setters. I would disagree with that, but you do want to have getters. So I want to get the account number and get the name. That would be something that I would add. The more to the point, and the withdraw method needs to be such that, so for example, that the amount in both withdraw and deposit needs to be positive. Otherwise, something is going to be off. And in addition, what if there's like $500 in the account and you invoke the withdraw method with $1,000? What should happen? Well, unless you have overdraft protection, then it will, like if you go to the ATM and try to withdraw more than you have or more than they allow, then they'll give you what they can, but they won't give you more. So the withdraw method as as written needs to be tightened up a bit. Okay, we're not going to do that just yet. Likewise, the deposit, yeah, both the deposit and the withdraw should make sure that the amount is positive. That needs to be clear. As far as that fee business goes, I would remove that. And actually, if there's a fee for withdrawal, then that would better be made as a static variable somewhere. Okay, but those are things that can be improved. Like the thing is that when you're developing a program, then you typically want to do it in incremental fashion. So if I were developing software that would ultimately be representative or be used for something like this, then this account class would be a reasonable place as a first step. And the important thing about this is that when you're developing these things, you want to do it step at a time. And so the thing is to do it like a first version, and then look at that and say, okay, what needs to be improved about this? In this case, kind of maybe having more getters. Setters would not, basically instead of setters, the deposit and withdraw are like the setters. And so that's what should be used for that. But this type of improvement to say, well, the methods as currently written are not ideal, so we want to improve them. The reason this is important is because if you try to implement the full Monty, just everything all at once, then the chances are you may not get there. But if you do it step at a time, then you stand a better chance. Okay, so let's look at constructors. So a constructor, notice that a constructor has no return type specified. Why? Well, because it doesn't make any sense to specify the return type, because the constructor always returns a reference to a new object of the class when you call it with new. When I say new and then give the name of the class, it calls the constructor constructs, and it returns a reference to an object of that class. So what could I put there as a return type? Could I put void? Well, that wouldn't make sense because I need to return that reference. Could I put a double or a primitive? Well, again, that doesn't make any sense because I need a reference to an object. Could I put the name of another class, not the class of this constructor? And again, that makes no sense whatsoever. So if I, for my account class, if it returns, say, a playing card in the constructor, that would make absolutely no sense, because as a user of this, I expect to create a bank account, and then you're giving me a playing card or a string or anything else. None of that makes sense. So the no return type doesn't mean it doesn't have a return type. It definitely does. It has a the return is a reference to the new object of the class. That's important to understand. Remember that. Now, there are some subtleties about constructors that are important to understand. In almost every case, you want to define a constructor, but if you don't, Java will define one for you. And the default constructor is one that has the name of the class with no arguments. So if you don't define a constructor, then it creates one for you. However, if you define a constructor, so as we did in the account, as you did in the playing card, if you define a constructor, then the automatic one is not created. So if I want a 0 argument constructor, in addition to, let's say, for whatever reason, in my account, let's see, where's my UML? Come on. Okay, if in addition to this constructor, I also wanted a 0 argument one, for whatever reason, I would have to explicitly do that. So once you write one, then it isn't there. But if you don't write one, if you don't write a constructor, Java will create one for you. You can have more than one constructors, but they must have different signatures. That is a different argument list. Now, the other thing to understand about a constructor is that the first executable statement on a constructor is either a call to super or a call to this. Okay, now we've seen the this already. We haven't seen super. And again, we're kind of peeking ahead a little bit. When it calls super, it invokes the constructor of the superclass. If you say this, then oh, this is wrong. This was this super. Oh, correct that. Okay. When it calls this, then it invokes another constructor in the class. If there's no other constructor, then of course you can't do that. If you don't write one, then what the compiler adds a call to super with no arguments. The reason this is important to understand is because this is happening under the hood a little bit. And then when we get to inheritance, this is a not understanding this is kind of can create a lot of confusing errors. In other words, you can write a class that looks perfectly fine, and Java will be complaining. And the complaint will not make any sense, because not all of the error messages that you get make sense. It will only make sense if you understand this. And we're going to circle back to this, but I wanted to plant the seed for this. So part of the look ahead is the fact that we have an inheritance structure. So just peeking ahead, and it's the words are a little bit confusing. There is a class that Java provides, and that class is named object. Notice that there's a capital O. This is a class, and that is the terminology gets very, very confusing. And so if you get a little bit muddled by this, don't worry. Hopefully things will be cleared up. There is a class, and that class is called object. That object class is the granddaddy of all classes. So this account class that we had is actually a subclass of object. In fact, every class that you have written, and I have written, and anybody in Java has written, is a subclass of the object class. When we delve into inheritance, this will become a little bit more clear. But this is kind of there's actually kind of the UML has a way of representing it, and this is it. So for example, let's see if I can do this without ending the show here. Oh. Keep that. Where are we here? Okay, so Okay, in my account class, notice I added extends object. That's how you do inheritance in this, and you're not responsible for this yet. Notice it's not complaining. I get there's no red squiggly. And so this is, if I write a class and I say public class account and I don't say anything else about it, then this is extends object is implied. I don't need to keep that. Okay. So coming back to this. Okay, so we can add a second constructor. Oh, yeah, that's what I was going to do. Yeah, we're going to add a second constructor that initializes the account to 0. So here's how we do that. And now I still am going to need okay, so notice that I'm allowed to do this, but then it's giving me a thing. It says variable account number might not have been initialized. Okay, why? Because I defined that to be final. I added final to that because it was being suggested. Okay, so now this is an example of where I used this. So what does this do? This calls account, passing it the name, the account number, but with an initial balance of 0. So let's see how that would work. Let's define. Oh. Okay, so now here, notice that I'm calling the constructor with 2 arguments, not the third one. And so if I and let's okay, so what's that going to look like? Okay, there's that account, there's the number, and there's the balance. And I can do, whatever. Like if I want to deposit some money in there. Okay, so here's where things are going to be a little bit flaky. Supposing I withdraw $50 from this, and let's give what's the fee? $1.50 is what they're charging. All right. We'll see that my account is overdrawn. Okay. So that's why the withdraw method needs some fixing. Okay, let's instead of that, let's just withdraw it. Okay, so so this, as written, allows me to infinitely withdraw however much I want. And it will just sort of happily give it to me. So that is not the greatest thing to do. Okay, so that's why those improvements are important. Okay, so next steps. So we're now finished with chapter 4. So for tomorrow, read the first couple sections of 5.1 and 5.2. That should be review for all of you, because that has to do with Boolean expressions and if statements. In your previous languages, you have all used if statements, I assume, if they were doing their job. So all of the if stuff should be review for you. It's just that Java does things in a slightly different way than the scripting languages.